Next example that I'm going to show you is about simply number of threads outside and inside of the parallel region. In this example, I have created a test file and it's based on OpenMP. Before the pragma, I write printf number of threads and then I get the number of threads. And within the pragma, the block or the construct, I say print the thread number of thread from the number of threads says hello world. And you see that for the first variable here, I just invoke the thread number. It returns the ID of the current thread that is running this region parallel. And then I use the routine get number of threads, which returns the number of all threads that are running this region parallel to each other will be printed in this placeholder. And after coming out, after joining or reduction here, you see that I print finished and go out. Let's test it. I just use G++ and I call the output file test, and I use the important OpenMP keyword to make it possible to run to parallelize my program during the compile. And I should give the input file that I want to compile. It will be compiled. There is no errors. That's very good. Now I should run it. I use the name that I have specified for the output. And you see at the beginning, it's the number of threads, just one, before going to the parallelized section or construct. But after entering the parallelized section, exact comment prints 8 instead of 1. It means I got 8 cores which run these threads, and each of these threads got a number and they print their own ID. That is also another example how to use pragma and print out the number of the threads and the number of the current thread. In this example, we are going to learn how the first private and last private works as the directives that we use in OpenMP. I have here again an example. It's also a simple C program that we have an integer value, a variable with a name of I. It is an integer and it has the value 10. Then I use the pragma to make this construct parallel using the parallel keyword. And then I said the variable I is private here. And then I try to print the number of the thread that runs this section and also the variable, the content of the variable I, the value of the variable I. And then I change the value of I. And after exiting the parallel section, I'm trying to print the I out. So this is a simple program that shows that the I is private, and we're going to see how it actually works. We said the parameter, the private, if you define a variable private, it will be copied for each thread within the synchronized region. And after finishing the region here, it will be deleted and the value will be undefined again. So it means the variable that we have defined at the beginning will not actually get involved in this section. It should be only defined that the compiler can find the type and the type of it. So let us go out and compile this using G++, -o, private as the output file, and don't forget f OpenMP, and then you can use the input file private.cpp. It compiles very good, and you see that if I execute the private, the value of I is in each thread 0, but at the end the value is 10. It means we look at the code again. We just printed the number of the thread, and the default value of I, it is 0. The default value within the thread is 0. It will be initialized by the compiler, but the value is undefined. We should set it. It's the default value in C++ compiler. And each thread has its copy, since we changed that in each thread, but the changes are not reflected neither here and nor and here. Means the value of the I is locally changed, and it will be deleted after exiting the construct or parallel region. Now let us define the I as first private. And save it using Control O and then Control X. Now I'm going to compile it again using the same structure. And if I run it, you see the value of the initial value of I for each thread is just the 10. It is copied from the parent, from the global variable. And finally, the value is the same, and the same with the parent, because we have changed the I value within the section, within our parallelized section. But you see that after finishing the section, the value will not be stored, and it gets its previous, the variable gets its previous value. Now let us try the last private. We open this file, and I change only the first private to last private. Save it and exit. Then I try to compile it. Then we need fopenmp, and we need private.cpp as input. Oh, there is something wrong. The last private is not actually permitted to use for the construct. It's used to get the last value of a variable in a loop. So we are not allowed to use it in this form. We should change it to the, we should change it in that way that we have a loop there, not a construct or parallel region. Therefore, I open it again. And I should actually change here the construct to a loop and write a loop with the value of, I have defined the counter as I say I is from 3. I should be under the value of 6, for example, and I++. Now we have a 4, which is able to get run in parallel. Let us remove this line because it brings more complication. And store the file and try to compile it again. You see, there is no error anymore. And we can also run the private. And you see the last value of the private variable I is 6 because we have defined it between 3 and 5. And the last value will be returned here. That you know that in some cases that you write programs, you need to know the last value, especially if you are going to work with some maximum, finding some maximum and so on. Now there is one point that there is one issue that we should talk about it, and it's the number of the threads. As you saw in the test example, I have 8 threads here, but where are they from? Why I have 8 threads, and how can I change the number of the threads? There is an environment variable that we should set if we want to have our program parallel. So let me show you what happens if we don't set it and how to set it. Now I just write exit. I just exit from my command line and open the terminal again. And if I run the test, for example, I have one thread. Huh? What's happened? Or if I run the private, it's running with one thread. You see, all the threads have the ID 0. However, I have parallelized it, but the threads that I parallelize it with one thread. So what's wrong here? We should set the number of threads that we need. And that is in that way, you can either use the export or you can set it in your program. So if I want to use export as a environment variable, you say OMP some threads like 5. And if I run the test now, you see I have 5 threads. And if I run the private, you see that I have 3 threads that they run my for loop. I don't need more than 3 threads, therefore it's okay. And you see, I don't need to recompile my program. I can just put the number of threads and run my program in parallel.